Hello everyone, welcome to my channel. I would be teaching you navigation and regulation. So let's begin with navigation, chapter 1, direction, latitude and longitude. What is navigation? It's a technique which enables a person to go from one place to another. Let us talk about Earth. Earth is the third planet from the Sun in our solar system. Earth is not a sphere, it is oblate spheroid, which is somewhat flattened from the poles and bulged out from the middle. This flattening is called the compression, and in case of Earth it's 1 by 300, which is equal to 0.3%. This is the Earth's polar diameter and this is the equatorial diameter. So due to the shape of Earth, the polar diameter is 23 nautical miles less than the equatorial diameter. If the equatorial diameter is x nautical mile, then the polar diameter would be x minus 23 nautical miles. And 1 nautical mile is equals to 1.852 kilometers. So 23 nautical mile would be somewhat equal to 43 kilometers. Since Earth is neither a sphere nor a perfect ellipse, thus we define Earth shape as geoid. Geoid means Earth shaped. Earth shaped. A number of different agencies have measured and modeled the Earth and produced their equations to define their geoids. For example, some European countries uses the European Datum 1950 model, and the USA uses World Geodetic System 1984. These two different models can create discontinuities. So ICAO, that is the International Civil Aviation Organization, has adopted World Geodetic System 1984 as the world standard. So now let us talk about poles. Earth is assumed to be spinning about an imaginary axis, and the extremities of this axis is called the poles. These are the extremities, and this is called the North Pole and this is called the South Pole. The axis of the pole is inclined to the axis of the Earth's orbit around the Sun at an angle of 23.5 degrees. The next thing which we are going to study is direction on the Earth. The direction in which the Earth is spinning is called east. And facing east, the pole on the left is defined as North Pole. The opposite of North Pole is the South Pole. And this is the west direction. When viewed from the above North Pole, the Earth appears to rotate anti-clockwise direction. So there's a trick to remember this. If we are viewing from North Pole, so the Earth appears to rotate anti-clockwise. This is anti-clockwise. And if we are viewing from South Pole, the Earth appears to rotate clockwise. So this is just a simple trick to remember. So these directions, north, south, east and west, are termed as cardinal directions. And there are more directions like northeast, northwest, southeast, southwest. These are called quadrantal directions. Quadrantal directions. Sexagesimal system. To define directions more accurately, we use this system. In this, we are defining directions using degrees and minutes. These directions are true directions. These are not the magnetic directions, and we will learn more about true directions and magnetic direction in further videos. Great circle. A circle which cuts Earth in two equal halves and whose center and radius are those of Earth itself. Now let us discuss some properties of great circle. Great circle is the circle having greatest area. We can draw infinite great circles on the Earth. This is the equator. Equator is itself a great circle. Like this, we can make infinite great circle on the surface of Earth. Now the third point is the shorter arc of the great circle is the shortest distance between any 2 points. So let us assume that we have to travel from point A to point B. There would be a great circle passing through these 2 points. So this is the shorter arc of the great circle, which you can clearly see is the shorter distance. Small circle. A circle on the surface of Earth whose center and radius are not those of the Earth. If this is the Earth, so this is a circle on the surface of Earth whose center and radius are not of Earth. This is also a small circle. This is also like this. We can have infinite small circles also. Now let us talk about equator. A great circle whose plane is 90 degrees to the axis of rotation of Earth is called equator. Meridians. Semi-great circles joining north and south poles and cuts equator at 90 degrees. So this is a semi-great circle and it joins north pole and south pole, and if we see, it will cut the equator at 90 degrees. Meridians are parallel at the equator and converges as it goes away from the equator. So we can see here, these are the meridians. So it is parallel at the equator. These two meridians are parallel at equator and are converging as they are going towards the poles, towards the north pole and south pole. These meridians represent east and west, which are longitude, and the maximum value of these meridians are 180 degrees. Meridian and an anti-meridian forms a great circle. Prime meridian or the Greenwich meridian. The meridian passing through the Greenwich is called the Greenwich meridian. It is the datum for defining longitude. Now we will talk about parallels of latitude. Small circles on the surface of Earth whose plane are parallel to the equator are called parallels of latitude. These are the small circles and their plane is parallel to the plane of equator. So these are parallels of latitude, and their function is to indicate north or south of the equator. This is north of the equator, and these parallel of latitudes will indicate south of the equator. In this figure, you can see prime meridian, meridians, parallel of latitudes and equator. This is forming a grid, and this grid is called graticule. Position is defined by angular measurement, that is degree, minutes and seconds of arc, and not by distance as on Cartesian coordinates. For accuracy, we have subdivided degree into minutes. 1 degree is equals to 60 minutes, and 1 minute arc is equals to 60 seconds of arc. Let us talk about latitude. The arc measured along the meridian through the point from the equator to the point is called latitude. So, latitude of any point A will be the arc or the angular distance which is measured along the meridian through the point from the equator. This will be the latitude. Let us suppose 40 degrees. This is the latitude, 40 degrees north. The latitude can be measured up to 90 degrees north or south, or 90 degrees south. Geocentric latitude. The angle between the equatorial plane and the radial line connecting the center of the ellipsoid to the point on the surface of the earth is the geocentric latitude. And the geodetic latitude, it is the angle between the equatorial plane and the surface that is normal at the point on the ellipsoid, is the geodetic latitude. Now, the maximum difference between the geodetic and geocentric latitude occurs at about 45 degrees north or south and is about 11.6 minutes of arc. There are some special cases of parallels of latitude. On 66.5 degrees north, we have Arctic Circle. On 23.5 degree north, we have Tropic of Cancer. On 0 degree, this is the equator. On 23.5 degrees south, we have Tropic of Capricorn, and on 66.5 we have Antarctic Circle. So we have to memorize all these. Longitude. The angle made by the shorter arc along the equator between prime meridian and meridian through the point is called longitude. So let's assume that this is the prime meridian and this is the meridian through a point A. Now, the angle this shorter arc is making along the equator is defined as the longitude. We have to remember this point that when giving a position, the latitude is always quoted first and the longitude second. Now, let us learn how to convert latitude and longitude into distance. For that, we need to understand what is 1 nautical mile. 1 nautical mile is the length of 1 minute arc of great circle. Minute arc of great circle. So, if this is a great circle, the 1 minute arc, this distance would be called as 1 nautical mile. Now, for example, difference in latitude between position A, that is 50 degrees 0 minutes north, and 1 degree 0 minute west, and B, which is 50 degrees 5 minutes north and 1 degree 0 minute west, is exactly 5 minutes. You can see it here. The difference in latitude between positions A and B is exactly 5 minutes. So this means the 2 points A and B are 5 nautical mile apart. Antipodals. The diametrically opposite point on a great circle are called antipodals. For example, if we have to find the antipodal of point A, that is 40 degrees north and 20 degrees east, then the antipodal would be point B, which is 40 degrees south and 160 degrees west. So this 160 is actually the reciprocal of this longitude, that is 180 minus 20 degrees, which comes out to be 160 degrees, and it is in opposite direction, so east becomes west here. So 160 degrees west. Antipodals will be on opposite hemispheres, as you can see, and on the meridian, one would be on the meridian and one would be and the other would be on the anti-meridian. Great circle vertices is the point of highest latitude on great circle. If this is a great circle, so this is the north vertex of this great circle, and this is the southern vertex. So, and you can see this is the point of highest latitude. If we draw equator here, you can see this great circle will cross the equator at 2 points whose longitude is 90 degrees removed from either of its vertices. If we remove 90 degrees from either of these vertices, we'll get the longitude of these 2 points. The great circle will cross the equator at an angle equal to the latitude of its vertices. This means that if there is a great circle with vertices 50 degrees north-south, this is 50 degrees north and this is 50 degrees south. So it will cross the equator at an angle of 50 degrees.